We're on this computer, share screen. All right, so I want to just discuss, so I discussed basically this comparable last lecture. Let's also double check to make sure, and let's see what our status is, because again, this semester moves very fast. So we got to see where we are on the semester timeline. I got to constantly check that. Because I think we also have, let's see, I think next Monday is also off because of, because of July 4th, which is weird that they knock that. So modules. Yeah, so I have this array list exercises due today. And then our first exam will be due. Really have that. And then we have the big O exercises due tomorrow. And then solitary encryption or Josephus the next day. We'll see how that. We can probably push those back, but we'll see. Okay. We'll see where you are on that. Okay, so where we're standing with this one. So for the assignment due today, here is permutation 1, right? So we can have. So one way I showed you how to do it this way if we wanted to sort if basically we wanted to sort the lists to tell if they were permutations. But issue with that is that not everything can be sorted, right? What if I wanted to see if two lists of scanners were files or something that's not comparable are permutations of each other? So how do we go about doing it that way? So let's go ahead and see. Well, what we need to do is that we need to go ahead and compare every item to every item in list A to every other item in list B and count them. So essentially what I mean is that for every item in list A, I need to count the number of times it appears in list A and count the number of times it appears in list B and see if that's different. So for E item in list A, right? That's just a for each loop like I did in my videos. I'm really fond of them because that's a lot short. That's pretty short. So for every item in list A, what I'm going to do is now I'm going to go through, write two other for loops. So int count A is equal to 0, int count B equals to 0. So what I'm going to do is for every item, the number of times it appeared so far in A has been 0. The number of times it appears in B so far is 0. I know it technically you'd think it appeared once, but I'm going to go through and now I'm going to loop again. So for I is equal to 0, I is less than list A dot size. And I'm just doing this to keep it fairly straightforward. If list A dot get I dot equals item. So if these two, so if the ith item is equal to item, then the number of times it has appeared in A goes up by 1. And now we just do the same for B. So for every item in A, I look through it, and so I mean it is on the one hand it is kind of straightforward the way to program this. On the other hand, it's kind of messy looking because you've got this for every item in A. Let's iterate over every item in A and every item in B. So you've got like a loop that goes over itself in the same exact way in the inside itself, which is kind of a mess, right? So we count the number of times that item has appeared in A. We've counted the number of times it appeared in B. Now, what do we have to do? So, well, now we ask, hey, if count A is not equal to count B, then we're in trouble. Return false, because permutations had to have the same number of items occur the same number of times. Okay. And if we can get through all of this, then we can return true. Okay. And we don't need to do this for B because of this, because we've already kind of taken care of that by checking the sizes and making sure that everything in A appears in B. And if everything in A didn't appear in B, then we'd have issues. All right, let's go to the next and talk about remove all instances. So I was talking about remove all, just to speed things up here. I want to just kind of show you the pitfall, right? So remove all instances. We want to remove all instances of E item from this list. Okay. And this is the way that I see that you probably program. If you've tackled this one yet, this is the way you've probably tackled it so far. And if you haven't yet, this is the way you would most likely tackle it, which is you say, okay, for each index in the list. So for int I is equal to 0, I is less than list dot size. So what I'm going to do is say list dot remove, not item, but yeah. For every item, what I'm going to do is I'm going to say, hey, if list dot get the ith item dot equals the item I'm looking for. So if list dot get I is equal to the item I'm looking for, okay, then what do? I'm going to try removing that item. List dot remove the index at I. Okay. And warning. Suspicious list dot remove in the loop, right? Kind of warns that you don't want to necessarily do that inside a loop like that, but it can be tricky because we're about to see. So let's go into main. I'm going to create, so I tell you, test it on, so most students program this and then tell me they're done because they don't test it on what I showed them to test it on. So I'm going to show you a different thing to test it on. It's fine. List of strings. So what we're going to do here is list of strings, words.hello, words.add, hello, apple. Let's go ahead and copy that a few times. Words.hello, apple, 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 words dot add banana. Okay. Banana, 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 banana. Okay. And now let's go ahead and say remove all instances from words of, I want to remove all the apples from there. Okay. Now, so we're going to sout words right now. So we're going to print out words beforehand, and we're going to print out words afterwards. We don't, and again, this is a void method. It's affecting the list being passed in. So let's go ahead and run it. And we'll see that basically that we tried to remove all the apples, but there's one left over. Why is there one left over? Well, which one got left over? Well, if I remove those 2 apples, we're going to see that it's one of these apples where there were 2 in a row got left over. In fact, anything where you have 2 in a row, let's try removing banana instead, you're going to have things left over. with the way. So here I tried to remove all the bananas, but that did not work. Even though every time I saw a banana, I removed it, which means one of two things, right? My statement was, if I saw a banana, I removed it, which means one of two things. I didn't remove the banana when I saw it, which is highly improbable because I just used the remove method that was built in. So what was the other part of that statement? If I saw a banana, I removed it. If I saw a banana. So there's two things I have to question, two assumptions I have to question. Seeing the banana and removing it. Okay. So, and we kind of just said, we need to look at the whole removing thing. Got a warning here. So, but it's the seeing thing here. So what if we're not seeing all the bananas? And that's actually what's going on here. We're not actually seeing all the bananas. And you'll need to think about why that is for the solution. But at the end, so what happens when you remove something from a list, from an array list, right? If you remove something at index I, then what was at I plus 1 shifts down to index I. And then what was at I plus 2 shifts down to I plus 1, and so on and so forth, right? When you remove something, everything shifts back, shifts down. And if you don't account for that, well, now you're just going to skip over what was in I plus 1, but it's now in I when you do I plus plus. So you need to find a way to account for that somehow. And there's multiple ways to do that. Yes.
If it's true, we can go I minus minus and we remove it.
Yeah, there's multiple. Yeah, that's one way to do it. There's actually a number of ways to do it. All right. Anything? All right. So that's what I've got for you in terms of recording right now.